So what about the definite integrals? Well, we'd use the same kind of idea, right? Generally, the question for a definite integral is going to say, okay, can you evaluate these definite integrals? Going to have bounds here. And they'll often say leave in exact form. That's pretty common for stuff like exponentials or logs or trig, right? So rather than just straight up putting into your calculator, they actually want you to leave it in terms of like e, or in this case e, right? So if I take the integral of e to the 2x from 0 to 2, for example, right, I can do that. I've done that a few times actually, that same example. So we know that the integral of that is just going to be, well, my a value is 2 here, so I'm going to have 1 on 2 e to the 2x, right? And we use square brackets when we're evaluating definite integrals, right? So I've got from 0 to 2. And then we just go ahead and substitute values in. Now at this point, what you might want to do, depending on the function, right? In this case, it's a bit small, but I generally tend to factorize out the half as well, just because it means I have to substitute less things. So I'm going to do that. And then I'm going to substitute in my values. So when I do that, I'm going to change my bracket. So I've got e to the 4 minus e to the 2 times 0, which is 0. Now, I just want to stress that anytime you see 0, students often kind of think, oh yeah, it's just the whole thing's going to come 0, so don't have to worry about it. This is where we start to see that that's not always the case, right? Because if you have e to the 0, that's actually a numerical value. That's just 1, right? So the way I can simplify this and leave it as exact is going to be 1 over 2 e to the 4 minus 1. Okay, and so that's my evaluated definite integral. Yeah. Let's look at another one. What about this guy? So from 2 to 5, and we're looking at e to the 5 minus 2x. So they may like to write things in different ways, but we can always use the same kind of approach, right? Because here I've got an a value and a b value. If you'd like to, you may even want to write this out in the way you're used to seeing it, because right now my a value is kind of on the right part of the expression. So I'm going to just rewrite this so it's really clear what's going on here. So my a value is -2. So this is the one where I want to be dividing by. So that's going to be 1 over -2 e to the minus 2x plus 5 from 2 to 5. Okay. And so just going ahead and evaluating, substituting. And this is why I factorize out the half, right? So I don't want to even think about that anymore. So let's go ahead and do that. 2 to 5. And then I can go ahead and evaluate. So here I'm going to get e to the, well, it looks like a -10 plus 5. And here I'm going to get, so remember we're subtracting now, because that's our definition of evaluating integrals. So here I'm going to get e to the -4 plus 5. So minus 2 times 2, right? And then I've got e to the -5 minus e to the power 1. And your textbooks may even go a step further, and they may say, okay, well this I can write as a positive index. I can write it as 1 over e to the 5 using your index laws minus just e. Okay. So that's how we can evaluate exponential functions using definite integrals.